Accommodative Arching, the science behind natural performance.
Whether we're seeing the smiling face of a loved one or a favorite television show, our eyes are our windows to the world. Whether near or far, the young eye can focus on just about any object. But what happens inside the eye to make this possible? As early as the 1930s, Fincham theorized that the eye's natural lens flexes and arches. The purpose of this video is to illustrate this accommodative flexing and arching, which take place in both the natural crystalline lens and in today's accommodative intraocular lenses. As the focus changes from distant to near objects, the ciliary muscles contract, the ciliary fibers slacken, and the crystalline lens becomes more rounded for near vision. This process is known as accommodation. One way to analyze the function of the eye and to capture the dynamic that occurs when focus shifts from far to near and back again is to use wavefront measurements. Wavefronts are 3D images that map how light rays travel through the eye. The wavefront images in this video are color-coded. Green indicates distance vision, red indicates near vision or myopia, and blue indicates hyperopia. For example, this is a wavefront map of the younger woman's eye focusing on an object in the distance, such as the TV. The image is all green, which indicates excellent distance vision. The eye is healthy and working normally. This wavefront shows the same eye focusing on a near object, such as a magazine. This wavefront has a red hotspot in it, which indicates a dramatic increase in the near focusing power of the eye. As the red spot increases in power, the blue area surrounding the red spot decreases in power. This is a normal accommodative response in a younger person. As we saw earlier, during the process of accommodation, the natural lens becomes more rounded for near vision. As we get older, however, our eyes lose the ability to accommodate. We may develop cataracts, which cloud the natural lens and can prevent a clear image from forming on the retina. This wavefront map measures the visual errors that people with cataracts experience as glare and other problems. Patients may choose to replace the natural lens with an accommodating intraocular lens. Like the natural lens, the Crystalens creates accommodation from distance to near vision by moving along the visual axis. Both the original crystalline lens and the Crystalens also arch or change their radius of curvature to increase their accommodation. They both move anteriorly and flex or arch to increase their focusing power in the intermediate and near ranges. Now, let's compare the wavefront maps for the natural lens with those for Crystalens. Let's start with the wavefronts for distance vision. In this example, both women are watching TV. The wavefronts are quite similar. They are both all green, which means normal distance vision. Now, let's compare wavefronts for near vision. In this example, both women are reading a magazine. Once again, the wavefronts are quite similar. As the wavefront comparison indicates, arching of the central lens takes place in both the natural lens and Crystalens. Now we'll take a look at how vision changes over a lifetime and how an accommodating lens can simulate normal accommodation. This is a normal lens at age 20. The distance wavefront is close to ideal for all adults. The near wavefront is slightly different. There is a more generalized change in the wavefront at this age than later in life. This is a normal lens at age 30. The distance wavefront is very similar to the 20-year-olds. However, the near wavefront image has changed. We find a decrease in the overall intensity of the accommodative response, along with a tendency to localize the effect in the center of the lens. Here we have a normal lens at age 40. The distance wavefront resembles the others we have seen. It is mostly green and nearly planar. The near wavefront continues the progression that started at an early age. The accommodative effect is more localized in the center of the lens. This is the eye of a 60-year-old man who has Crystalens implanted in both eyes. His distance wavefront is similar to the others we have seen, meaning he has excellent distance vision. His near wavefront image shows accommodative arching and resembles the wavefronts of the 30 and 40-year-olds we saw previously. We can now bridge the generation gap with accommodating lenses. They allow us to restore the near and intermediate vision of our middle adulthood. And as we've shown through detailed wavefront analysis, both the natural lens and the accommodating lens arch or change their radius of curvature to produce clear vision at any distance.